Today we're working through the Manchester Grammar 2014 paper. So we've done the 2013 and the 2019 now. We're going to start the next one. So it's very similar in format. So why don't you just have a quick look at those first 3 questions and work them out on paper, and you can send me the final answers in chat. Remember, for number 3, there is a quick way of doing it rather than long multiplication. I'm just going to start talking about the first one. So 300,000, the number 300,000 on its own looks like this. And then you've got 407. So you just put those together. But it's usually helpful to put a comma in there so you can see that you've got 300,000 rather than accidentally putting 30 or something. So 300,000, 407 should look like, just make sure that looks like a comma, like this. Okay, starting to get some answers through. Okay, so adding the next one. 569 plus 372. Hopefully you all know how to do that one. And then for number 3, the quickest way of doing it would be to do 418 times 7 and then add a 0 on the end. I'm starting to get some answers through. Just 2 more seconds for those. Moffat, you got the last digit in number 2 wrong. So be careful, guys. And Emily got the middle digit in number 2 wrong. So I know you're trying to be quick with these, but remember, in an exam, these are the easy questions. So you can't afford to make silly mistakes because you'll lose easy marks. Okay, good, we've got some corrections through from my friend Emily. And then 418 times 7. Poppy, I think you might have got the digits wrong on the multiplication. So do 418 times 7, then add the 0. I'm just going to give you the answers now so you can move on. 941 and 29260 for the third one. Okay, next, work out 17.5 divided by 5. Now, I know that some of you haven't done this, done division of fractions yet, because it doesn't tend to come up in your exams, but we'll just go over it for the sake of completion. So 17.5, first of all, we need to write that as an improper fraction. So hopefully you can all give me the improper fraction from 17.5. What does that make? So 17.5 is an improper fraction. Remember, you'll do 17 times 2 and then add it to the 1. Not quite. So, yeah, 35 over 2 divided by 5. And 5 as a fraction is 5 over 1. It's 5 wholes. So we're going to flip the second fraction and we're going to multiply. Okay, now if you are familiar with multiplying fractions, then you can challenge yourself a little bit by cross-cancelling. So 35 and 5, we have to have one numerator, one denominator. Someone's unmuted. Can you make sure you're muted, please? I can hear you. Okay, so 35 and 5 both divide by 5. So we get 7 and 1. And then we'll multiply those numbers together. So we do 7 times 1, multiplying the numerators, and 2 times 1, multiplying the denominators. So we get 7 over 2. So 7 over 2 could be the answer. I would prefer to write it as a mixed number or as a decimal, so it would be 3.5. Okay, next question, number 5. Now remember, with a number sequence, I've said before, always write the difference between each number down on paper because it will help you to keep track of the pattern. You can give that one a quick try. All right, so we are getting some answers for number 5 that are in the right vicinity, but some of them are a little inaccurate. So make sure you are writing these down and being careful. This is another one where it's easy to get the mark if you are careful. And the difference between these is 15. So we should be adding 13 here, and then you would have to add 14, hopefully, to get 83. So you just need to do 56, add 13, which would be 69. Make notes like that, and then you're far less likely to go wrong. Right. Work out 2.42 times 1.6. Now, multiplying decimals, remember we take out the decimal point, so you will calculate 242 times 16 using long multiplication. And then when you get the answer, you'll put the decimal point back in. So just very quickly, if you can you calculate 242 times 16? Then I'm going to give you my calculator answer for that in a second. Okay, so that makes, I'll give you 2 more seconds to calculate. Okay, some of you are getting the answer. So 242 times 16 makes 3,872. Now we have oops, that's a bit big. We have 1, 2, 3 numbers behind the decimal point. So we do 1, 2, 3 numbers behind the decimal point in the number, and we put the decimal point there. So our answer is 3.872. Okay, number 7, write 0.64 as a fraction. If you're not sure what the denominator should be, just look at the column that the last digit is in. So the 6 is in the tenths, but the 4 is in the hundredths. So that means this number is going to go over 100. If we had 0.064, then the last number would be in the thousandths, and so we'd do 64 over 1,000. But that's not what we have. So we have 64 over 100, and do not forget to simplify. 64 and 100 both divide by 4, although if you hadn't spotted that, you could divide by 2 and then divide by 2 again. And you get 16 over 25. And that's as far as that fraction will go. So our answer is 16 over 25. Okay, now the next question. If the following numbers were written in order from highest to lowest, which number would be in the middle? This is made trickier because we've got a mixture of fractions, decimals, and a percentage. So the best way I'd say of putting them in order would be to write them all as a decimal. I think that's going to be the easiest one. You need them all either in the same format, so all as a percentage, all as a fraction, all as a decimal, but I think the decimal will be the easiest in this case. So write down what the numbers are as decimals. Get it down on paper, so don't try and do that in your head, and then number them so they're in order. I'm going to start doing them from left to right on the board for anyone that wants to check their work. So 3/10 would be 0.3, because then 3 is in the tenths column there. 1/3, now I know 1/3 is 0.3 recurring. So some of these fractions, hopefully you'll just know what they are equal to. For the purposes of this question, having 0.3 recurring and 0.3 is a bit confusing. So what I'm going to write instead is 0.333, because it will make it easier to compare to the others. I know it's going to carry on with the 3's for eternity, but I'm just going to write the first 3. 1 sec. Okay, so that's 1/3 is 0.333. 1/4, some of you have told me, is 0.25. 0.75 is 3/4, not 1/4. And then 0.35 is as a decimal already. And 33%, to write that as a decimal, you just divide by 100. So Ali had given me that one. It's 0.33. Now, if you're having trouble putting these in order, which is fair enough, what I would recommend is adding zeros to the ends of the numbers so they're all the same length. So our longest number here is 0.333. It has 3 digits there. So to order decimals accurately, I would add zeros so they all have the same number of digits after the decimal point. Add a 0 here, add a 0 here, add a 0 here. And now we can almost look at those like they're whole numbers. So if we were to cover up the 0, imagine that's covered with this. No, that's not much better. But cover up the 0 and the decimal point. You can do that with your finger on paper. And then you've got 300, got 333, 250, 350, and 330. So you should be able to put those in order, just imagining that they're whole numbers. And the reason I can do that is because they all have 0 at the front. They all have the same number of units. Okay, just give you a second to order those, and then you can send me the middle number. Okay, remember to send your answer just to me. And also, with these questions, you need to make sure that your answer is in the format of the original question. So if you converted a fraction into a decimal, for example, your answer would need to be as a fraction, not the way that you wrote it to make the question easier. Okay. Yeah, remember guys, 0.33, so 33%, that's going to be slightly smaller than 1/3, because 1/3 was 0.333, that had that extra little bit at the end. Okay, I'll just put them in order quickly on here. So our smallest is 0.25 or 1/4, second, 0.3, third, 33%, fourth is 1/3, and then fifth is 0.35. So our middle number is 33%. Okay. So some of you, if you didn't get that right, just try and find some ordering decimals work at home. If you're in my regular classes, you can remind me, or perhaps ask your parents if they can give you some practice. Okay. All right. Next question. Alison watches 2 quiz programs on TV. The first is on from 6:35 p.m. until 7:15 p.m. The second lasts for half an hour. Later on, she watches a film from 9:30 p.m. until 11:25 p.m. In hours and minutes, how long has she spent watching TV? Okay, so let's find out the length of each show, first of all, and then we'll add them together at the end. So, first one, we've got 6:35 until 7:15, then we've got half an hour, and then we've got 9:30 until 11:25. Just underline those so I know what I'm looking at. 6:35 till 7:15. The easiest way to do this, I'd say, would be to figure out how many minutes it is to 7 p.m. and then how many minutes to 7:15, and add those together. So 6:35 to 7 p.m. is 25 minutes. And then 7 to 7:15 is 15 minutes. So that first program lasts 25 minutes plus 15 minutes, which is 40 minutes. Right, 40 there, so I can keep track of each. Second one, half an hour, that's 30 minutes. And then the third one, 9:30 until 11:25. What I would do with this is go too far forwards and then go back. I'll show you what I mean. Okay. 9:30 to 11:25. Sorry, I didn't mean to write that. Let's go 9:30 to 11:30, and then we'll go back the 5 minutes to 11:25. So 9:30 to 11:30 is 2 hours. 11:30 to 11:25 is minus 5 minutes. So how long is that second program? It's 2 hours minus 5 minutes. Some of you are racing ahead and I'm getting a lot of wrong answers. So hold on. You clearly need to take some time here. Okay, so 2 hours minus 5 minutes. How long does that second program last? Yes, Sri. So the second program is 1 hour and 55 minutes. Should add some units here. 1 hour and 55 minutes. Now, once you've got all of those numbers written down nicely, remember to jot down the answers as you go along, because otherwise you're going to get confused. Then we need to add them together. How you do this is up to you. I would put 40 minutes and 30 minutes together to get 70 minutes, which is equal to 1 hour and 10 minutes. Now, if we put 1 hour and 1 hour together, we get 2 hours. If we put 55 minutes and 10 minutes together, we get 65 minutes. But what's wrong with that answer? Can I put 2 hours and 65 minutes as my final answer? Nope, I cannot. We've got too many minutes. So what is the correct answer? What is 2 hours and 65 minutes in hours and minutes? Yeah, thanks. So I've got that from Undina and I got that from you, Olivia, a little earlier as well. Okay, good. So 3 hours and 5 minutes. So it seems like a few of you were overconfident with that one. You rushed ahead and then I got a ton of wrong answers. So you need to be more careful, take your time, write a timeline like I did where you're showing how many minutes between each one, and that will help not only for you to stay accurate, but also when you're checking through your answers, you'll have all that working down so you can see if you were correct. Okay. Ollie is making some small snacks for a party. He cuts 1.2 kilograms of cheese into a number of 15-gram pieces. How many pieces does he have? Now, we have a question that's similar to this in the mock, where there's some division with large numbers, and children often get put off. So I'm going to show you a couple of ways to do it. So just concentrate. Don't do anything on paper right now, because I want to just show you how you can do this. You'll probably know one way, but perhaps haven't thought of the other way. So our first problem is that we've got kilograms and grams. We don't want that, so we want both of the items to be in the same units. So we'll make this 1,200 grams divided by 15. So this would be the way most people would do it. So just take your time with this and make sure you're carrying the right amount. The usual problem is that children don't carry properly. So 15 into 1, that's 0. Carry the 1, or you can join them up if you want. Now 15s into 12, also 0. And now we have to carry 12. Remember what I said about not working it out on paper and just concentrating? Okay, so 15 into 120. You probably don't know your 15 times table, and that's okay. So use what you do know to estimate. So we know 15 times 2, for example, is 30. That's too low. 15 times 10 is 150, and that's too high, but it's kind of close. So I would say do 15 times 8, and if you're not sure, you can do 15 times 8 over to the side, see what you get. You get 120. So 15 goes into 128 times, and then don't forget to try and put it in that last 0 as well. So 15 into 0 goes 0 times. So our answer is 80. Sorry, my iPad came to life there. Right, now the other way that we can do it to make it slightly simpler is writing it as a fraction first of all. So if we do 1200 or 1200 divided by 15 or over 15, we can simplify this fraction and then do the division afterwards, if you still need to. So let's see, I know 3 goes into both of those numbers. Okay, so 1215, they both divide by 3. That's 400, and that's 5. So then you can do 400 divided by 5, 0, carry the 4, 8, 0, and you'll get 80 as your answer. So you get the same answer, you don't have to do anything to that answer, but if the division is tricky, try writing it as a fraction, simplifying, and then doing the division. So our final answer here is 80. All right, next one. So on a large weighing balance at Chester Zoo, the zookeepers find that 5 rhinos on one side will balance 6 zebras and 3 rhinos on the other side. How many zebras would be needed to balance 9 rhinos? This one requires a bit of thought, so I'm just going to give you a little bit of time to try and work it out. So try and do it on paper. Okay, most of that was quick. I'll start doing my notes for it. Okay, so 5r equals 6z plus 3r. Now the 3 rhinos on each side will cancel each other out. If you imagined a weighing scale, it would be a very big one, but if you imagined it, then if you've got 3 rhinos on each side, those cancel each other out. So that means you've got 2 rhinos are equal to 6 zebras. So you can do that algebraically by doing minus 3r on both sides. So 2 rhinos equal 6 zebras. So 1 rhino equals 3 zebras. Now just make sure when you do the 9 rhinos that you get things on the right side. So I would write it as ratio just to be sure. 1 rhino is to 3 zebras, and then it's 9 rhinos. Times 9 times 9. So got some final answers, yeah. 27. What you don't want to do is end up with that 9 underneath the 3 and then get in a muddle that way. Yeah, so someone's asked me just to go over that again. That's fine. So, okay. We start off with an equation that just shows what the information they've given to us. The 5 rhinos equals 6 zebras plus 3 rhinos. We can take minus 3, we can subtract 3 rhinos from each side, because they kind of cancel each other out. If I had R on one side, 6 zebras, if that's your scale, then 1, 2, 3, cancel out 1, 2, 3. So we know 2 rhinos are equivalent to 6 zebras, which means 1 rhino is equivalent to 3 zebras. And once you've got that ratio, you can just put that into a ratio problem here, and then it says how many zebras would be needed to balance 9 rhinos. So you put 9 on the rhino side, and then you times each one accordingly. Okay, so our final answer there is 27, sorry. Let me just see. No, you can't use ratio the whole time because it's not, this side isn't a multiple of this side at the beginning. Ratios for when we have like 3 times as many on this side as that side, whereas this is a mixture. So you would have to start with algebra or logic to figure that one out. Okay, start reading the next one. I'm just going to clear up my board a bit. Okay. A rectangle is 4 centimeters longer than it is wide. The distance all the way around the rectangle, its perimeter, is 32 centimeters. What is the area of the rectangle? Now, we've done some questions like this using ratio, where one side is maybe 3 times as large as the other. I don't think we've done an example like this before, so You have the skills, but you'll have to combine a couple of different topics that we've done. I'll give you a second to think about it. Remember, guys, if you're answering the question, please don't send the answer to everyone. What I don't want you to do for this is trial and error, by the way, because there is a proper way of doing it. Now, for anyone having trouble, the perimeter is the sum of 2 of the lengths and 2 of the widths. Sorry, I just realized I needed to change my screen. Okay, so 2 lengths and 2 widths makes the perimeter. I need to find out what 1 of the lengths and 1 of the widths add up to. So I'll do the perimeter divided by 2. So the perimeter divided by 2 is 16. So 1 length and 1 width must add up to 16 centimeters. And the length is 4 centimeters longer than the width. So I'm going to do 16, take away 4. So I'm taking off the difference between them. That's 12. And to halve that number, and then add the 4 back on, add the difference back on. And therefore I get 6 and 10 as the length and the width. Now remember to reread the question so that you're answering what they've asked, because our answer is not 6 and our answer is not 10. So the area of the rectangle, we're going to have to multiply those. So 6 times 10, it's 60. Let's see. A few of you got that one. No, I think some of you have missed that because you were doing your own thing. So I'll brush through it quickly again, but next time you need to listen more carefully, okay? So the perimeter is 32. That's 2 of the lengths and 2 of the widths. So half of that is 16. So 1 length, 1 width is 16. The difference between the measurements is 4. So I take 16, I take off the difference, divide that by 2 and add the difference back on. And that gives me 2 numbers that add to 16 where the difference is 4. Then finally the question wanted the area, so I multiply those. Okay, stop any work on the previous question because we need to move on to the next one and I don't want you to miss any part of the next explanation. Now, the mean length of a crocodile is 7.5 meters. The mean length of an alligator is 4 meters. If I have 4 crocodiles and 6 alligators, what would be the mean length of all 10 creatures together? So remember, mean, you add up all of the numbers and you divide by how many numbers there are. Just first, you need to figure out what the numbers add up to. I'm going to write times 4, and times 6 next to these, so I don't get in a muddle. 7.5 times 4, we could double it and then double it again. So that would give us 30. And then the alligators would give us 24. So if I add up all of the animals' lengths, I get 30 plus 24 is 54. And then there are 10 creatures altogether. So what we would need to then divide by 10 because there were 6 alligators and 4 crocodiles. So we do 54 divided by 10, which is, still not seeing the right answers. So we've effectively added them all up, 30 plus 24, and then divide by 10. Yes, Sri, good. So 54 divided by 10 would be 5.4 meters, and I check the units of measure that they've asked for just to make sure I don't need to put it in centimeters or something. 5.4. Okay, next one. Hopefully you should all be able to do this one. In the summer sales, prices of items are reduced by 15%. What would be the sale price of a coat, that originally cost £30. I'll give you a minute to work that out. Please remember to reduce. So often in exams, children find 15% and then they don't reduce it at all. Okay, good. Our first answer. Good, Andina. Maisha, you'll have to have another look at that. And you haven't reduced. Actually, Maisha, I think I know what mistake you've made, and it's a common one. So you haven't reduced, that's the second thing. But first of all, finding 15% of £30. Now, you can do 1% if you want. 1% we divide by 100, that would be 0.3, times by 15 to get 15%, that's 4.5. Now, I'm not going through how to find the percentages because I'm hoping that you know at this point. Now, 4.5 written as money, this is where you have to be careful. We have to add a 0 to it, but the 0 has to go on the end. You can't put a 0 just in the middle of a number. It doesn't work. So we have 4.50. So it's 15% is £4.50. And then when you reduce £30 by that amount, then we get £25.50. Because it's money, we have to have two numbers after the decimal point, just like we did here, £25.50. Don't make the mistake of writing 25.05, because that's only 5 pence, not 50 pence. Okay, next one. This is a straightforward arithmetic question. So I would imagine pretty much all of the children sitting the 11 plus should have the ability to work out a question like this. You just have to be careful so that you don't make silly mistakes. So, a cow eats 8 kilograms of food per day, and a pig eats 6 kilograms of food per day. A farmer has 30 cows and some pigs. If the animals eat a total of 360 kilograms of food each day, work out how many pigs the farmer has. Give it a go for me. First of all, figure out how much food the cows eat on their own. You don't have to tell me that answer, but figure that out first and then do the second part. Okay, good, Isla. Mothe, you need to take another look at that. Good, Livia. Yes, Poppy. Should we take another look? And okay. Seems the girls are getting this, and then the boys aren't right now. So boys, be careful. Okay, yes, we have our first boy got it right. Well done, Thomas. Okay, I'm going to start doing it on the board in case anyone's confused. So 8 kilograms of food. So a cow eats 8 kilograms of food. He has 30 cows. So cows, they have 8 times 30, which is 240 kilograms. Okay. Kalisa, I think, may have a division error there. I'm not sure. And then we have, I'm not sure who iPad is, but it's not 15. Okay. So a pig eats 6 kilograms and he gives 360 kilograms of food. So after you've taken off how much the cows have had, you do 360 to take away 240, and you've got 120 kilograms left over. If each pig eats 6 kilograms each day, hi Christian, sorry about that, 6 kilograms, then we do 120 divided by 6, and we get 20. So our answer should be 20. Oh man, none of that came up on the board. Paused. Let me try again. There we go. The cows eat this much. We take away that from the total amount of food. the pigs are eating 120 kilograms, divide by 6, and you get 20 pigs. Okay. Next one, probability. This is just like one that we did last week. So Tim has a box containing 9 red, 6 blue, and 5 yellow counters. He picks one counter at random without looking in the box. What is the probability that he will not select a red counter? Give your answer as a fraction. So not select a red counter. The easiest way of doing this is figuring out the probability that he does select blue and yellow, blue or yellow. So figure out the probability that he selects blue or yellow, and then you're done. Good, getting lots of answers here. Yes, Tanya, Shri, Manan, Mofe, Emily. Yeah, those are all correct. I'll just give the others a couple more seconds. Mofe, you sent it to me privately and publicly. That's no good. Yes, Poppy. Okay, I'll talk about it to anyone that's confused. Good, we've got lots of right answers, well done. So the probability of blue or yellow is just going to be how many blue or yellow counters there are over the total number of counters. So there are 11 blue and yellow counters, and in total, when we do 9 plus 6 plus 5, there are 20 counters altogether. So that's our probability, 11 20ths. That's it. Okay, right, all concentrating really hard for this next one because it is not easy. David cuts a 6-meter long pole into 3 different pieces. The largest piece is 40 centimeters longer than the middle piece, and the middle piece is 70 centimeters longer than the shortest piece. What is the size of the largest piece? I'll give you a second to think about how you're going to approach it, and then we'll do it on the board. Olivia, yeah, I would use the age problem method as well. Shri, that is going to be too big. I think that was too quick. I don't think you could, I mean, you could work out the full answer in that amount of time. That's okay. You don't know where to start? We shall work it out. Okay, good, Christian. I'll show you how we do it on the board. I'll be interested to see if it's the same method that you used. So the largest piece, and Poppy, by the way, I'm going to use a method similar to the one that we used in yesterday's class with the ages. You'll see what I mean. So the largest piece is 40 centimeters longer than the middle piece. And the middle piece is 70 centimeters longer than the shortest piece. So I just draw a little diagram like that. I show that the middle piece is 70 centimeters longer, and I show the largest piece is 40 centimeters longer than the middle one. I now need to write everything in terms of the smallest amount. I mean, I said youngest because I'm used to doing this with ages. So in terms of the smallest amount. So the small is just equal to small. That one's easy. The medium piece is equal to the small piece plus 70 centimeters. And grab Poppy. Keep following just so make sure you get the final thing. And then the large piece is the small piece plus how many centimeters? Large piece is the small piece plus how many centimeters? Yes, Tamer, 110. Now I'm going to add those together. So I have 3 S's, 3 small pieces, plus 180 centimeters. And that equals 6 meters, but as I'm working in centimeters, I'm going to write 600 centimeters. Now, if you hadn't got this far yet, can you try and figure out what a small piece is worth based on that equation? So 3 small pieces plus 180 centimeters equals 600 centimeters. So first, what do 3 small pieces equal? Yes, Carla, that's good. Yeah, Melon, well done. So 3 small pieces will equal 420, which means 1 small piece is 140 centimeters. Then you can either go back to your diagram, so long as you're confident this is accurate, or the original question. And don't forget to reread the question as always to make sure you are answering the right part of the question. So the largest piece was 110 centimeters larger than the smallest piece. So we do 140 plus 110, and then we get 250. Good. Quite a tricky one, they're getting harder now. So the largest piece is 250. I think a lot of you have that. Good. Okay, I'm going to move on to the next lot. And I have some illustrations for these, but let's read the question first. 2 bags of crisps and 5 chocolate biscuits cost £1.76. If each bag of crisps costs 4p more than a chocolate biscuit, what is the cost of a biscuit? So 2 bags of crisps, 5 chocolate biscuits cost £1.76. Each bag of crisps costs 4p more than a chocolate biscuit. Now I have some images. I don't have an image of a chocolate biscuit. I have images of chocolate because it was easier to find, to be quite honest with you. So we've got the question here. I've got my 2 bags of crisps, 5 chocolate biscuits, and then that costs £1.76. So I know obviously you can't draw this in an exam, but I'm hoping that seeing it will help you to visualize the problem, which will make it easier to do in an exam because you'll understand where all of this is coming from. Just ignore the pennies at the bottom for now. So 2 bags of crisps plus this, £1.76. Now we can't figure out what each item is worth because we've got too many things that we don't know. We've got crisps, we don't know the price of the crisps, and we don't know the price of the chocolate biscuits. If I can get it down to just chocolate biscuits, then I can figure this out. So each bag of crisps costs 4p more than a chocolate biscuit. I'm going to replace each bag of crisps with a chocolate biscuit and 4p. So let's see how easy I can do this. So instead of that bag of crisps, I have a chocolate biscuit. Sorry guys. And 2p. And then instead of this bag of crisps, I have a chocolate biscuit and 2p. So this has the same value, sorry, not 2p, two 2p's, so because they're 4p more. So these have the same value as the 2 bags of crisps did. So now I know 7 chocolate biscuits plus 8p equals £1.76. I'm going to go back on here. So 7 chocolate biscuits plus 8p equals £1.76. So 8p is in 8 pence. Can someone tell me what 7 chocolate biscuits equal? Just the 7 chocolate biscuits. Okay, Olivia. Try and slow down. Okay. So if 7 chocolate biscuits plus 8p equal £1.76, if I take away the pence, take away 8p from both sides, then 7 chocolate biscuits make £1.68, which a few of you have told me. And if 7 chocolate biscuits make £1.68, you should be able to find out the cost of 1 chocolate biscuit. A few of you have said it, I think. If you are following along on the board, just figure out the cost of 1 chocolate biscuit for me. Check your division, Carla. So Jessica, that's the cost of 7 chocolate biscuits, but how much does 1 cost? Yes, I know. Thomas, that's the total still. Yes, Christian? Yep, Buffet, Kalisa, Kramer, yep. So 1 chocolate biscuit must cost 24p. So I just replaced the 2 bags of crisps with the amount of chocolate biscuits they were worth plus the money. So it was still staying even. We'll do more examples like that soon. You need to keep going over it. Or this video will be on YouTube after this, so you can also rewatch the class and then follow it through on there. Okay, number 19. Start a new page because we need some room. Okay. How many odd 3-digit numbers is it possible to make using the numbers 4, 5, and 7 if you are allowed to use each of the numbers more than once in a particular 3-digit number? So we need the numbers to all be odd. So what does that tell us about the 3-digit numbers that we will have? If the number has to be odd, then the numbers we produce have to have what? Have to not only have 5 and 7, Emily, but I think you mean end with 5 or 7. So all of our numbers have to end with 5 or 7. Remember, we can use each number more than once. So using just these numbers, you can use them more than once. What is the smallest odd number I can produce with these numbers? So just tell me the smallest odd number you can produce. Smaller than 547. Moffy, you're close, but not quite. It's smaller than 457. And Ariel, smaller than that. Christian, you've given me the smallest number, but remember it has to be odd. Yes, Maisha, you the first one to give me the smallest odd number. So 445 is the smallest odd number that we can produce using just those digits. Now, what's the next smallest odd number? So try to keep the first couple of digits the same if you can. You want to change as little as possible to get the next number. Yes, Ariel, good. So 447 is our next one. Okay, pause there because I can see that I reckon some of you are going to get carried away. Start doing this on your own and then you're going to miss the explanation. So 445 and then 447. The 2 smallest ones. What's the next smallest one? So we're going to stay in the 400s if we can. We can't have any other numbers in the 440s. So what's the next smallest? I'm not sure whether these were answers to the question I asked or the previous one. Yes, Tamer, that's the first one I'm sure of. So 455 is the next one. And then after that, we get 457. Shri, what did I say about following this on the board and not doing it on your own? Because you were going to make mistakes. Stop, please. Okay, so 457. And then we can't have any more numbers in the 450s, so we go up to the 470s. Yes, Tamer, so 475. And what's our final one in the 400s? 477. Okay, so maybe just take a second, check that we've got all of the 400s numbers that we could possibly get from those digits. Hold on, everyone, do not go any further. Okay, and then as we finish the 400s, we will have to go on to which hundreds? To get the next smallest number that we can get. The 500s, yes, Tamer. So we get 5. And what's the smallest 500s number? Yes, Kalisa, Olivia, so 545 is the next smallest 5s number. Then 547. But hold on a second. This is starting to look familiar. So you see how the 10s are the same as in the 400s. And that's going to continue in that order. So if we had 6 numbers in the 400s, then we will have 6 numbers in the 500s as well. And then we would do the same for the 700s, and that would start 745, and it would proceed in the same way as the previous ones. So we'd have another 6. So all in all, we can make 18 odd numbers. Thanks for Christian and Emily. 18 odd numbers using those 3-digit numbers. Okay. So by writing these out systematically at first, we've saved ourselves time with the last lot, and by going through them in order, then we can make sure that we haven't missed anything out, forgotten anything, that sort of thing. Okay. Number 20, this is always our hardest one. Now remember, in this particular exam, the last couple are always the hardest, and also they're the ones that require, they're quite tedious. You have to go through a lot of steps and be very careful and be systematic. If you were tight on time in an exam, especially this one, because you get 1 mark for each question. So if all of the questions give you the same number of marks, don't spend 20% of the time in the exam on one question when you could go back and answer the easy ones correctly. So remember at the beginning, quite a few people got the multiplication or the subtraction wrong. It's probably better to just quickly check those answers, make sure those are in the bag before you spend a long time trying to figure out a hard question. But if you've got the time, go for it. Just be careful. Okay, so the number 3 can be split in 3 different ways by adding positive whole numbers together as follows. 1 plus 2, 2 plus 1, and 1 plus 1 plus 1. Using the same method, in how many different ways can the number 5 be split? Now, one thing I noticed here is how 1 plus 2 and 2 plus 1 count as 2 different answers. So we'll have to keep that in mind when figuring out how to split the number 5. I have just some circles for you to help us with this question. Hang on, I'm going to copy the question over. Okay. So the number 3, so we're splitting the number 5 in as many ways as possible. So let's start with just 2 groups. So 1 and 4. Why don't you write down each of these numbers for me? Now listen carefully, because I'm getting some answers from you, but they're wrong, so just follow along on the board, okay? So the first option we have is 1 plus 4. And remember what I said about being allowed to switch the numbers round. So not only do we have 1 plus 4, but let's write down 4 plus 1, because we know that's one option as well. So then, what else can we have? So instead of just 1 over to that side, let's have 2 and 3. Still getting wrong answers from you. Sending the same answer again doesn't mean it's right now. Follow along on the board. Okay, so 2 plus 3 and 3 plus 2. So that's the only way that we can have 2 groups of numbers. And remember, by the way, 3 plus 0 wasn't included here, so I can't have 5 plus 0. Okay, so we have 4 options written down so far. Now let's start at the options that look a bit like this. So 1 plus 1 plus 1 plus 1 plus 1. That is an option. Oops, didn't mean to add a new page. And then the 1 plus 1 plus 1 option, that can't be reversed. Now what if we have 2 plus 1 plus 1 plus 1? Now that can be reversed. 1 plus 1 plus 1 plus 2. But there is another way well, there are actually a couple of other ways that we can arrange these numbers so they're in a different order. Ariel, we'll come to that option in a minute, but just focus on this option right now because we don't want to miss any of these variations out. So how else can we write the addition with 1, 2 and 3 1s? The 2 needs to go in a different place. We put it at the beginning, at the end. Yeah, in the middle. And then there's one other variation. Yes, and second. Good. Okay. So we've done all the options we can do with 2 being in different places and still adding up to 5. Can you just have a look at the 3 option for me? So if I have 3 and 1s, what variations can I get on that? Maisha, you keep ignoring my request to follow along on the board and you're giving me a ton of wrong answers. You're going to end up finishing this and not knowing why they were wrong. Okay, so 3 plus 1 plus 1. Olivia, yes, so if you move the 2 along each time, you could do it that way. You're right. Yeah, and then 1 plus 3 plus 1, and then 1 plus 1 plus 3. And those are all the variations that we can have with 3 and 1s. We've already covered the variations that we can have with 4 and 1s, so we don't need to do anything there. Now, there's another way that we can split these. There's one final way that we need to cover. Can anyone think of the other way? Ariel, I think you mentioned it earlier. How else can we split these units? Yes, Ariel, so 2 plus 1 plus 2 is what you've given me there. That's not going to work. Okay. If I have 2 plus 2 plus 1, and then I move the 1, so 2 plus 1 plus 2, and then 1 plus 2 plus 2. Let's add those up because I think we've got all the options we could have. So we have 4 here, 3 here, 3 here, 2, and 3. I'm putting a line through them just so I don't double count or miss anything out. So 4 plus 3 plus 3 is 10, plus 3 plus 2 is what? What do I have? Yes, Emily, so 15. Shri, you've given me 4 plus 0 plus 1, but remember I said if we look at the initial example, they could have had some zeros in here, but they haven't included any. So answers with zeros don't count. We have to refer to the question so that we're sure. Yeah, good, everyone. So we have 15 different options for number 20. Let's write my answers in here so you have them. So 15, this one was 18, and this one was 24. Okay, what I think I'll do, so we're at the end of the paper for today. I think a few of you were still a bit confused by number 18. So if you would like to go over that one again, then stay on here, we'll go over it again. And then if not, then you can head off and I will see you in the next class. So bye to those of you that are...
Bye.
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 See you.
Bye.
Thank you. Bye.
Bye.
So 2 bags of crisps and 5 chocolate biscuits cost £1.76. If each bag of crisps costs 4p more than a chocolate biscuit, what is the cost of a biscuit? So 2 bags of crisps and 5 chocolate biscuits cost £1.76. Can you mute for me, guys? I can hear someone. So if each bag of crisps costs 4p more than a chocolate biscuit, what is the cost of a biscuit? Costs 4p more than a chocolate biscuit. What is the cost of a biscuit? So I need to replace this with chocolate biscuits plus however much more the bag of crisps cost. I can't solve the equation. I can't figure out what crisps and biscuits are at the same time. So I need it to all be the same. So instead of 2 bags of crisps, I have 2 chocolate biscuits plus 8p. Because each bag of crisps is 4p more than a biscuit, 2 bags of crisps would be 8p more than 2 biscuits. Does that make sense so far?
Yes.
Okay. So that is now that. That looks like a 6, but it is a B. B. Okay. Plus 5 biscuits equals £1.76. So and then I put the biscuits together. I've got 2 biscuits here, 5 biscuits there. So I have 7 biscuits plus 8 pence equals £1.76. So if I take the 8p away from each side, I get 7 biscuits equal £1.68. Now stop me if that's too much. You want me to go back over it?
No, it's okay, I've got it.
You've got it, okay. So then you can find out the cost of 7 biscuits.
Yeah.
Okay. And the cost of 1 biscuit, therefore, is £1.68 divided by 7.
£24p?
Yeah, 24p. So 1 biscuit costs 24p. This isn't the question, but how much does a packet of crisps cost? Do you want to send it to me? The cost of a bag of crisps? It's not getting any answers from you. Does each bag of crisps cost 4p more than a chocolate biscuit?
Is it 28p?
28p, yeah.
Yeah, okay.
The cost of a biscuit was 24p. All right, that is it for today. I'll see you in next classes, okay?
Yeah.
Bye.
Thanks for joining us again. Don't forget to subscribe to our channel so you're the first to know when new videos come out, and to give this video a like if you found it helpful.